Hey YouTube channel, thank you for clicking on my video for the law of conservation of energy. So today, we have here, I have a spike ball and a lacrosse ball. The spike ball, it has a significantly less mass than this lacrosse ball. If you ever gotten hit by this, you know. So, today, I'm not lying to you, there is no tricks. This entire thing is made out of aluminum flashing. It is extremely light, is flexible, can be sturdy with support, but it is very smooth and very sharp on the sides. This was extremely dangerous, I understand, for the team of engineers who were cutting it, building, sawing all day today. I am very thankful for them again. Now, what I want you to do is click here if you think the spike ball will have a higher velocity or the lacrosse ball. Okay guys, so here's ball number 1, the lacrosse ball. From the top, 3, 2, 1. Okay guys, here's ball number 2, the spike ball, different mass, same height. And in 3, 2, 1, go. Played both videos back, congrats to those who guessed that the balls would have the same velocity. Now why is that? Why is the ball with the smaller mass, why doesn't it, go slower? Why doesn't it have a slower velocity at the end? Well, even though both balls have a different mass, at the end they both traveled 0.9144 meters once you do all the conversions, and they both, as you can see in the slow motion view, they both traveled the same distance in 4 seconds. That means they have the same velocity. Now, but why is that? Conservation of energy states that energy can't be created nor can it be destroyed. So it's saying the sum of the energy equals or is the energy final equal to the energy initial, assuming that there's no other non-conservative forces like friction or anything else, or air resistance. Now, if the energy final equals the energy initial, what do we have in the beginning? At the top, let me redraw the figure, comes down, swings up, comes down a little bit, a little hill, and it swings down to the bottom. Now, all that stuff I told you in the beginning, I got you. The height doesn't really matter. I mean, it's important that they're both the same. And at the end, the height is 0, same distance in between, that's how we calculated the velocity. And everything in between, it doesn't matter. Because the law of conservation of energy states that the energy final has to equal the energy initial. And the energy initial, as we know, it wasn't moving in the beginning. There was 0 velocity, so it didn't have kinetic energy. There was only potential energy, and the potential energy was gravitational potential energy, mgh. So this mgh initial has to equal the end energy, or the final energy, which is the movement, which is the kinetic energy, which is 1/2 mv squared. That's the final energy. Now this is why the velocities are the same even though the mass is different. Look, the masses cancel out. I don't even have to write 2 different equations to calculate or find out that the masses mattered. They don't. The mass is negligible as well as the friction and everything else, because I can still derive an equation either way.
If young Metro don't trust you, I'm gonna shoot you.
Yeah. Yeah. Halloween.